we're doing the vector between 2 points. So I'm actually going to start with the little second part of this example going from P to Q. There's a formal equation for it, and what you do is you take all the coordinates of Q, so that's 1, -1, and 3, and then you take off all the coordinates from P, so that's -3, 1, and 2. And if you do that, you're going to get a new vector. That'll be 4, -2, and 1. But what I actually prefer to do, personally, is look, how do I get from 3 up to 1? Well, I add 4. How do I get from 1 down to -1? Well, I take 2. And how do I get from 2 up to 3? Well, I plus 1. And if you write that in as a vector, that's sort of the vector P to Q. So that's sort of the two ways you can do it. Now we'll come back and talk about OP. So OP is literally just going to be the coordinates of P, -3, 1, and 2. But if you want to get really fancy about it, O is actually the point 0, and P is the point -3, 1, 2. So how do I get from 0 to 3? Well, I take 3. 0 to 1 is +1, and 0 to 2 is +2. That makes the vector -3, 1, 2, which is literally just the coordinates of P. So if you ever want to find the coordinates of a point, and you're talking about vectors, you want to find O to that point, essentially. Last one here is the modulus of PQ. So part C, modulus of PQ is just going to be modulus of this vector, 4, -2, 1. So that's going to be square root of 4 squared plus -2 squared plus 1 squared. So that's square root of 16 plus 4 plus 1, which is square root of 21, just like that. So what we've actually found there, this is the distance from P to Q. So if the question ever asks for that, you want to find the vector PQ first and then do the mod of that. That'll give you the distance between those 2 points.